Determine the slope and deflection at B and C. E is 200 gigapascals and I is 400 times 10 to the 6 mm to the fourth. Still, we solve this by double integration method. So first, let's solve for the reaction at A. Vertical and moment reactions. The horizontal reaction is 0, of course, because the loadings are all vertical. And that's MA. Let's assume positive MA always. Clockwise at the left, counterclockwise at the right for positive bending. So Ry equals 0 equals Ay minus 20 times 3, then minus 12. So solving for Ay is equal to 72 kilonewtons upward. Then moment equals 0 or summation moment equals 0. Clockwise positive as assumed. So MA equals MA plus 20 times 3 times 1.5 plus 12 times 5. So MA is equal to negative 150 kilonewton meter. Take note that for span AB, the moment of inertia is 2I. For BC, moment of inertia is I. So there is discontinuity with respect to moment of inertia. So instead of EIY double prime, we use E times 2I Y double prime AB. And that is only applicable for A to B. So let's have the distance, this distance x in general. So E times 2I Y double prime AB is equal to 72 times x, then minus 150 times x minus 0 to the 0 for this moment here. Actually, if it is at the origin or leftmost point, then you can just have minus 150 instead of quantity x minus 0 or x to the 0. But I want you to be accustomed to doing that, especially if there will be couple loads not at the origin but somewhere on the span, so that you will not forget to do that. Then that's it. Then minus the moment of this loading, 20 times x over 2, so minus 10x squared. So let's simplify this first by dividing everything by 2. So EI y double prime AB equals 36x minus 75 quantity x minus 0 raised to 0 minus 5x squared. So integrating once, EI y prime AB equals 18x squared minus 75x, just 75x to the 1 or 75x, then minus 5/3 x cubed. There is no c sub 1 because when x is 0, the slope at the origin is 0. So there is no c sub 1. There is also no c sub 2 because when x is 0, the deflection is 0. Both the slope and the deflection are 0 at A. So integrating again, EIY AB equals 6x cubed minus 37.5x squared minus 5 over 12 x to the fourth. And as I said, there is no c sub 2 because when x is 0, deflection is 0 or YAB is 0. We can now evaluate theta B by setting value here to x equals 3. So EI theta B equals 18 times 3 squared minus 75 times 3 minus 5/3 3 cubed. So solving for theta B equals negative 108 over EI. Of course, it's negative because it is sloping downward. The tangents are sloping down to the right. That's a negative slope. So since EI is 200 times 10 to the 9 pascals or 200 times 10 to the 6 kilopascals, kilonewton per meter square, times I 400 times 10 to the 6 mm to the fourth. So we divide this by 1000 mm to the fourth to make this meter to the fourth. So kilonewton per meter square times meter to the fourth, that would be 200 times 400. We can cancel 10 to the 6, 10 to the 6, and 1000 to the fourth. So that's 80,000 kilonewton meter square. That's the value of EI. So therefore, negative 108 kilonewton meter square, also kilonewton meter square divided by 80,000, that would be in radians. So theta B therefore is negative 108 over 80,000. So theta B in radians is equal to negative 1.35 times 10 to the negative 3 radians. You may not put the unit radian because it is understood if it is unitless, that is in radians. Likewise, for delta B, into this equation, we substitute x is 3. So EI delta B equals 6 times 3 cubed minus 37.5 times 3 square minus 5 over 12 times 3 to the fourth. So delta B is equal to negative 209.25 over EI. Then the numerator is kilonewton meter cube, denominator kilonewton meter square. So if we divide this by 80,000, it becomes meter. And since meter is a unit which gives very small value for deflection, so we convert that to mm by multiplying further by 1000 mm per meter. So that's in meter, so times 1000 mm per meter. So therefore, the shortcut to computing deflection in mm is, instead of multiplying 1000, we just divide it by 80. So whatever is the value here, divided by 80. If it is 100,000 divided by 100, that is automatic mm. So delta B in mm is negative 2.616 mm. So that's a very small deflection. Then for BC, to solve for theta C and delta C, we have to extend the load as shown, then counter it by an upward same load. And this will be our sectioning, that's X. So EI, because the moment of inertia is I for BC, so EI Y double prime BC is equal to 72 times X plus 150 X to the 0, then plus this loading upward 20 times X minus 3, the length is X minus 3, that's 3, times X minus 3 over 2, so that's 10 X minus 3 quantity square, then minus 20 times X over 2, so minus, for this loading here, minus 10X square. Integrating, so this is BC, definitely there is deflection and rotation for this part, so there is a constant of integration. So EIY prime BC equals 36x squared minus 150x plus 10 thirds x minus 3 cube minus 10 thirds x cube plus c sub 3. I will not use c sub 1 because c sub 1 is for the origin. But if we have a point that is not the origin, then we have another constant of integration, c sub 3. So for the origin, c sub 1 and c sub 2. For any other point, c sub 3, c sub 4, c sub 5, c sub 6, and so on and so forth. Then integrating again, EI y BC equals 12x cubed minus 75x squared plus 5 over 6, 10 over 12, 5 over 6x minus 3 to the fourth minus 5 over 6x to the fourth plus c sub 3x plus c sub 4. Now we can evaluate c sub 3 because B is common to AB and BC. And the slope when x is 3 at B is negative 108 over EI. So that's also the slope in portion BC when x is 3. So equating EI times negative 108 over EI equals 36 times 3 square minus 150 times 3. This is 0, then minus 10 thirds 3 cubed plus c sub 3. Solving for c sub 3. C sub 3 is equal to 108. Then take note 108. So we can now compute theta C by setting the value of x 5. So take note c sub 3 is 108. So EI times negative 209.25 for delta B equals 12 times 3 cubed minus 75 times 3 squared, and minus 563 to the fourth because this is 0, plus 108 times 3, c sub 3 is 108, plus c sub 4. Computing for c sub 4 in this equation, c sub 4 is equal to negative 114.75. So we can now compute theta c in this equation here because c sub 3 is found, 108. So EI theta c equals 36 times 5 square minus 150 times 5 plus 10 thirds times 2 cube minus 10 thirds times 5 cube plus 108 or plus c sub 3. So theta c is equal to 132 over negative 132 over EI, negative 132 over 80,000. So that would be equal to negative 1.65 times 10 to the negative 3 understood radians. Then finally for delta C into this equation, x is 5 and we already found c sub 3 and c sub 4. So EI delta C equals 12 times 5 cubed minus 75 times 5 square plus 5 over 6 times 2 to the fourth minus 5 over 6 times 5 to the fourth plus 108 times 5 plus negative 114.75 c sub 4. So delta C is equal to negative 457.25 over EI. So the shortcut, you just use 80, divide by 80. Automatic delta C is in mm. So delta C or deflection at C is negative 5.716 mm. So that's it for this problem. I hope you were able to follow the explanation and the solution.